Now for the third case, the angle is given with respect to the actual length d4. Okay, the angle is given as 30 degree to the line d4 but right now in top view the line has reduced in length. So let's first find out the length of our line d4. Okay, so the length is 42.43, but the actual length of d4 was 60. So the angle is given with respect to the length 60, and we need to find out the angle for the length 42.43. So for that we'll use the projection of line. Okay, so let's find out the new angle. I'll draw one small line. Now let's draw the line having length 60 degree and angle as 30. Okay, so this is the, from that point we'll draw one horizontal line which is nothing but the locus. Okay, let's put out the point name as, let's say this is point D, this one is point 4 dash. Okay, now the reduced length is of length 42.43. Okay, so with respect to D point we'll cut the locus line using the arc command. So for that, go to the draw arc, select the start center aim, specify the center. Now let's select the center as D. Okay, make sure your ortho mode is off. Provide the distance as 42.43. Okay, and let's draw an arc. So this is how the arc has been drawn. Now let's join the point D to the intersection point. Okay, this is the point 4. Okay, and let's measure the angle. So for that we'll go to dimension, select angular. So this angle we have provided as 30, and the new angle that we want is of 45 degree. So for the third case we need to use the 45 degree angle and not the 30 degree angle. I hope you have understood why we are finding out the new angle. If you still have any doubt, okay, you can WhatsApp me or you can mail me. Okay, let's proceed with the new angle. Okay, so we'll firstly draw one line, arbitrary length at an angle of 45 degree. Okay, now for the third case, as we have discussed this particular thing in classroom itself, that we are going to tilt our object away from the reference line. Okay, so for that we'll draw the 45 degree line like this and not like this. If you have drawn the 45 degree line like this, your object will get tilted towards the reference line. Okay, so make sure you must tilt your object away from the reference line. Now we have drawn one line, arbitrary length line at an angle of 45 degree. Now let's select the object. Okay, let's say let's copy it. Select the object, right click, say copy selection, select any one point. Okay, now we don't want this dimension, so let's select it and delete it. Now we are going to align our object with point D and 4. So let's use the command align. Select the entire object, say enter, select the first reference point as D. Okay, and then point 4, enter and say no. So this is how our object is getting aligned with the angle 45 degree. Now our object has been moved slightly above the reference line, so let's move it out. For that, select the object. Okay, we'll select entire object, say move. Okay, we'll move it below the reference line. Okay, this will be sufficient. Now this will be our final top view. Now to complete the final front view, let's transfer each and every point. Make sure your ortho mode is on. Okay, we'll transfer the point A, vertical projection of point A, then vertical projection of point B, similarly vertical projection of point E, point D, point C, then point 1, 2, 3, 4, then point 3, similarly point 4 and 5. Okay, so we have transferred all the points. Now let's transfer their horizontal projection. So these are the horizontal projection of 1, 2, then 3, 5, then 4, then AB, carefully draw the projection as many lines are close to each other. Okay, and D we have already transferred. Now select entire projection line, go to properties and change their color code to color code 251. Now let's find out the points using the point PO command. Now firstly we find out the upper surface 1, 2, 3, 4. So these are the vertical projection of point 1 and horizontal projection of point 1. So this is point 1. Next horizontal 2 and vertical 2. Okay, so this is point 2, horizontal 3, then vertical 3, so this is point 3, then vertical 4, horizontal 4. Okay, this one is point 4, last one vertical 5 and horizontal 5. So this is point 5. Okay, now let's find out the bottom surface ABCD. So these are the vertical projection of A, horizontal projection of A. So this one is point A. Next vertical B, horizontal B. So this one is point B. Next vertical C, horizontal C. So this one is point C. Then vertical D. Okay, vertical D and horizontal D. So this one is point D. And last one vertical E and horizontal E. So this one is point E. Okay, now we have find out all the points. Let's name it. Okay, so this one is point A dash. Next B dash. This one is C dash. The next is D dash. And the last point is E dash. Okay, now let's find out the upper surface 1, 2, 3, 4. So this one is point 1 dash. The next one is 2 dash. This one is 3 dash, 4 dash, and the last point is 5 dash. Okay, now let's join each and every side and edge that we know. So firstly we'll join the bottom surface A, B, then point C, D, E, and again A. Then the top surface 1, 2, 3, 4. So 1, 2, 3, 4, 5, and again 1, and their edges. So 1 to A is one edge, then 2 to B, 3 to C, and this 5 to D and E to 5. Okay. Let's color it first. Color it so that we could have proper visualization, like the green. Okay. Now, if you see carefully the final front view, we are able to see the surface 1, 2, 3, 4, 5, then the surface 2, 3, C, B, then the surface 3, 4, D, C. So these three surfaces are we are able to see first, and after that the edges are there. The edge is 1 to A, then A to B, and A to E. So these three edges will be hidden. Or if you see your top view, and for the front view we are seeing it from this side. So if you are seeing it from this side, you are able to see the surface 1, 2, 3, 4, 5, as well as the surface 4DC3, then the surface 2BC3. Okay, but you are not able to see the edge 1 to A. Okay, so 1 to A will be hidden. Okay, 1 to A will be hidden, as well as A to B and A to E. These three edges we are not able to see. So we'll select the edges which we are not able to see, as well as this particular, the fourth edge, this edge, which is inside the surface 3, 4, DC. Okay, and that edge is E to 5. So these four edges will be hidden. So we'll select these four edges. Okay, we'll go to layer and we'll make it as hidden. Now go to property and change the scale to 0.5 so that we are able to see the lines. Okay, so the edge E to 5, if you see it from naked eye, we are not able to distinguish, but if you zoom it, you will find out that your hidden edge is inside the edge D2, D to 4. Okay, so E to 5 will also be hidden. Okay, which is inside. Okay, so this is how we have completed our problem on pentagonal projection. Make sure to give the dimensions. Okay, let's provide the dimension. So we'll select linear. This one is 40. Then let's provide the angles. So this angle was 45, and the last angle that we have find out, okay, using the projection of line. Okay, this concept is very much important. You must thoroughly understand why we are doing this. Okay, if you have any doubt, you can contact me at any time. Okay, so this is how we have completed our problem. Hope you have understood the problem very well. If you have any doubt, just mail me your queries or you can WhatsApp me at any time. Okay, thank you very much.